Hello again. This is part three of the nature of science for college prep physics. And I want to drill and grill you. We've got to drill and grill you with the variables, okay? So we're going to ask ourselves again, what is a variable? And a variable could be anything. Could be an object, a thing. It could be an event that happens. It could very well be someone's ideas or feelings. Time periods are variables. Any category that we could actually measure and changes could be a variable. Variables are things that change or vary. Okay. So variation, variant, things are different or changeable. So in my experiment, there are always going to be three variables that I'm using. The independent variable, the one that we are testing to see if it has any effect, is going to change the dependent variable, which we're going to measure the results of. And there's always going to be some variables that have to be constant. These can be called controlled variables or control variables, or you may see them in some sources as constant variables. Let's drill you on independent variable. We'll look at the definition first. The definition of the independent variable is what is varied during the experiment, by the experimenter, of course. So it is what the investigator thinks will affect the dependent variable. In my classic example of fans in the classroom, the number of fans would be the independent variable. This is what I think is going to affect the dependent or the temperature variable. So the job of the number of fans would be to identify a possible cause of things happening. So I think in my hypothesis that if I increase the number of fans, then the temperature will go down. So if I change this independent variable by making more fans appear in the room, I go out to Walmart, buy a couple of box fans, throw them in the window, then that should have an effect on the temperature. It should cool it down for us. So the independent variable has some effect on the experiment. We are going to be doing graphing in physics because we're looking at cause and effect relationships. And we're also looking at measurements of those cause and effect relationships. A great visual of those numbers is a line graph. Line graphs show relationships. My independent variable, guys, I'm going to drill you on this one throughout the course, always goes on the x axis. A good example of independent variables would be time. And in our case of the fans, it would be temperature. Uh, like if you're testing how fast you could go and you look at miles per hour, the hour would go on the x axis uh, because how long you're driving depends on how far you go. And of course, the x axis is in pink here, it's horizontal. Horizontal x is the independent variable. In the case of the fans, the number of fans would go on the bottom on the x axis. The temperature is going to go on the up and down on the y. So I want to talk about temperature and when we talk about dependent variables. Let's give a definition again. A dependent variable, this is what is measured. It's what the investigator thinks will be affected during the experiment. So we said that fans could be the dependent variable or number of fans, more specifically. The temperature is going to react, it's going to be affected by the number of fans. So the definition is what will be measured or what the investigator thinks is affected during the experiment. It has one job, depends on other factors to do anything. Temperature can't change without having something affect it. So, can I just change temperature? No. Dependent variable only changes because of the independent variable. Meaning, if the temperature goes up or down in my classroom, does that mean that all of a sudden there were more or less fans? No, of course not. It's always the number of fans affecting the temperature. So, on our graph, when we do line graphs in class, we're going to do a y-axis for the up and down for dependent variables. That would be my temperature. The temperature would be graphed on the y. The temperature is affected by the number of fans on the x. The last set of variables that we talk about have to do with constant variables. These controlled variables are never changing. They're always held constant. So when you see the word constant and controlled variable, they mean one and the same. Now they have a job. It's that they eliminate the possibility of other factors affecting the results. I kept saying we have to test one variable at a time. So that means when you tested your fish lab, you had to test the same hand, the same person, uh, you had to be in the same room, you had to be the same time of day, the same height. All of those factors had to be the same. Whereas if you were running a race and trying to see who's faster, you can't have a good test with a track that is dirt versus a track that is mud. It's just not going to be the same. So, this job of the control variable eliminates all possibilities of a different variable interfering in our experience. So, guys, never, 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 ever, 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 ever change the controlled variables. You want one test per experiment. You're not going to get good scientific results if you start testing two things at a time. So keep your controls the same every single time. Do they need to be graphed? Nope. Controlled variables don't get tested, so they do not need to be graphed. All right, now this is different. Controlled variables are not the same as when we talk about a control group. You can have a control group versus an experimental group, and you can graph those two groups. But controlled variables, meaning the parts of the experiment, are not graphed. Why would they be graphed? They're supposed to be the same, supposed to be constant. We don't want to see any changes in controlled variables. So let's sum up independent versus dependent variable with this sentence. It's the independent variable that causes a change in the dependent variable, and it isn't possible that the dependent variable could cause a change in the independent variable. So I for independent, I manipulate the variable. I'm looking for a cause and an effect. My number of fans can change the temperature, but just because the temperature changes does not mean that the number of fans are going to change. Make sense? Let's expand a little more on an example with plants. All right, guys, controlled experiments are where a control group is compared to an experimental group. So here again, we're not talking about controlled variables per se, we're talking about an entire experiment. Let's look at what a control group would be with plants versus an experimental group. Here, a student grew a tiny plant in the classroom, and they left all the conditions under what a normal plant grows. It has plenty of light, water, the temperature is at room temperature constantly, and the plant seems to be doing well. Lo and behold, they wanted to experiment on the type of light, and here we have red light in a room, and look how the plants have shot up. Wow. So, do you see the difference between control and experimental? It's different groups being tested. Now, they would both have the same control variables of soil, type of seed, temperature, humidity, but one group has a different type of light. So, control variables are always different than control groups, guys. Control variables are these factors. You want to keep them to stay the same or constant in the experiment. Examples like in the plants would be temperature, humidity, or how much of a substance. Control group is the group in the experiment that is not being tested. Control groups do not get tested, they stay the same. Control variables have to stay the same, so your experiment is only testing one variable at a time. So, summing up what a variable is, these factors can change in the experiment. We only want to test one. You get an experimental group. The group is the experiment, and the control is not the experiment. The experimental group contains its own independent variable. That's the one factor in the experiment that I want to test. I for independent. This is what I'm changing in the experiment. Dependent variables, guys, it's a factor that's affected by the independent. Let's look at an example of a guy named Bob. No relation to that cartoon sponge that's copywritten and I can't use. You know, the one who lives in a pineapple under the sea. As of right now, I don't have the rights to put him on video. So I'm just going to say Bob. All right, let's take a look at SpongeBob. Let's take a look at my friend Bob. He lives in a pineapple under the sea and he doesn't have a driver's license yet, but he wants to know if his new formula for mosquito spray would repel more mosquitoes than the original formula. He thinks he's got an improvement going on. So he thinks that his new formula is going to repel more mosquitoes than his old formula. How do you think Bob could test this? All right. So Bob went camping and he took two groups of campers and they slept under the stars for one night. The first group used the old formula of mosquito spray, and group two used the new formula. So the next morning, Bob counted the number of mosquito bites each person had in with two groups. So there's a lot going on with this. He had two groups of campers in the same area, one night, same time. One group was a control group using the old formula. The other group was the experimental group. They used the new formula. And you could quantify the results by actually counting the number of mosquito bites. So the independent variable that's being tested here is this new formula. The dependent variable is how many bites you get. All right. I think we've drilled enough on variables. We're going to make an end to this presentation. Trust me, we're going to do nothing but go over variables with every single experiment till it's part of your vocabulary. Okay, bye.